Underwater structures are crucial to our modern world. They form the backbone of many essential operations beneath the waves. They support a wide range of activities, from transportation and energy production to scientific research and resource extraction. These structures enable us to explore the depths of the oceans, providing platforms for underwater research and drilling operations. Bridges, tunnels, pipelines, and offshore platforms all rely on these submerged structures. They are integral to connecting continents and transporting resources. As we venture further into the oceans, the importance of efficient and safe underwater construction methods becomes increasingly apparent. These methods ensure the longevity and stability of the structures. These structures face unique challenges due to the harsh underwater environment. Factors like pressure, corrosion, and marine life can impact their integrity. Traditional construction methods often involve significant risks and high costs. Divers working in difficult conditions face numerous hazards. The need for innovative solutions is clear. New technologies are being developed to address these challenges and improve safety and efficiency. Artificial intelligence is emerging as a transformative force in this field, promising to revolutionize how we design, build, and maintain underwater structures. With AI, we can anticipate and mitigate risks more effectively, ensuring the future of underwater construction is both innovative and secure.
Artificial intelligence, in simple terms, refers to computer systems capable of performing tasks that typically require human intelligence. These tasks can range from simple calculations to complex problem-solving and decision-making processes. These tasks include learning, problem-solving, and decision-making. AI systems can adapt and improve over time, making them incredibly valuable in dynamic environments. In the context of underwater construction, AI algorithms can analyze vast amounts of data, identify patterns, and make predictions that optimize construction processes. This means that AI can foresee potential issues before they arise. This data-driven approach allows for more informed decision-making, leading to improved efficiency, safety, and cost-effectiveness. By leveraging AI, construction teams can work smarter, not harder. Imagine an AI system that can analyze ocean currents, predict weather patterns, and adjust construction schedules accordingly, minimizing risks and delays. This proactive approach can save both time and resources. This is just one example of how AI is poised to transform the field of marine construction. The future holds endless possibilities as AI continues to evolve and integrate into various aspects of construction.
AI is already being integrated into various stages of underwater construction.